In this video, we're going to be explaining how to solve this quadratic equations and binomials problem here. The problem statement says, consider the equation x squared plus blank x plus 100. Find all possible values for the missing number here that makes this expression the square of a binomial. So before we continue, let's review what the square of a binomial is. So over here we have an x plus a squared, where the x plus a is in parentheses, and we have a squared on the outside here. So this here is a binomial, this expression. And a square of binomial is a square here. So this entire thing is a square of binomial. So there's a special formula we can use to find out what the expanded form of a square of binomial is. And basically what we do is we write this out like any other product we would expand. This is basically just x plus a copies 2 times of it. So we're just going to write this out as x plus a, 2 copies of this, x plus a times x plus a. That's all this is. It's just x plus a squared. All we have to do is write it out like this so we can see it easier. So then we use the distributive property. Distribute this in, x squared, outer terms, ax, inner terms, also ax, last terms, a squared. Then we combine like terms, the ax is here, and we get 2ax, x squared plus 2ax, plus a squared. So that's the expanded form of this here, a binomial here. And there's actually a special theorem that has to do with the square of binomials that comes in especially handy for these types of questions. So the theorem states that the constant term, which is going to be the a squared in this case, is going to be the square of half the linear term. The linear term is this, the 2ax, and this is the constant term. So the constant term is the square of half of the linear term. So in this case, this means that the square of the linear term is going to be 2ax squared. Let's write this in a different way so we can see this easier. X squared plus 2ax squared plus a squared. This isn't actually the equivalent here, but it's doing this to show the relationship between the linear term and the constant term easier. The theorem states that this here linear term, well, it's not linear anymore because we got a square on it, but this is going to be 2 times the linear term, and this is the constant term. So this is what would happen if we were to multiply the linear term by 2, and this illustrates the relationship between the linear term and the constant term, where the linear term is always, the constant term is always going to be half of the square of the linear term, and this applies to every quadratic, so we can replace a over here with any value we want. In this case, we've got 100 for a. It just could be any value we could use and apply this theorem to make it easier to find and factor quadratic equations. So that's kind of like a little bit of a side note there about squares of binomials. So we can then apply this over here to our main quadratic equation. So, the first thing we want to do whenever we want to find the possible values of the coefficient of the linear term here in this blank box, we want to look for any potential perfect squares in the quadratic equation. In this case, the perfect square that comes to mind right away is the 100. The 100 over here is a perfect square. 10 squared is 100, obviously. And this means that going back to our example for squares of binomials from over here, since the square root of 100 is 10, that means our linear term over here is going to be 10 over here. That's our linear term, our constant term. So in this case, our a equals to 10 because 10 squared equals 100. So this is the constant term here. That is 100, which means our a, we're going to go ahead and just write this down. A equals 10 because a squared, 10 squared is 100. So then we can use this information and the square of binomials theorem to figure out the blank number, the coefficient of the x here that goes in the box. So we know that what we have is the constant term is going to be the square of half of the linear term, as we discussed. So constant term is half the square of the linear term. That means all we have to do here is multiply this a equals 10, this constant term, by 2, because the constant term is going to be half of the square of the linear term. So literally all we have to do here is really simple. 10 times 2, because of the binomial theorem, equals 20. Now we have to be careful here because there is more than one value. It's not just 20, because we're dealing with squares here. As we know, we could have 10 squared equals 100. We could also have negative 10 squared equals 100, because the square of a negative number is still going to be the positive number that you would get by squaring the positive number. So we've got two answers here. We've got our 20, and we've got our negative 20, because both of those satisfy this equation, because it's basically the same thing as saying 10 squared equals 100, and negative 10 squared also equals 100. Then all we have to do from there is multiply the 10 by 2 because of the square of binomial theorem here with the 2ax. That's basically the central point here. So both the values here that satisfy this expression and makes this entire expression the square of binomial, 20 and negative 20 here, that's the two values that we're looking for that will go in this blank spot. That will make this equation the square of binomial. So that's pretty much how to solve this quadratic equations and square of binomials question in Algebra 1. All we have to do here is use the square of binomial theorem, where the constant term a squared is going to be the square of half the linear term 2ax. And then you apply that back to our original equation. You find whatever the square root of the perfect square term is, in this case 100, find the perfect square, take the square root, multiply by 2, and then make sure you have all the values by checking if there's a negative value. There's almost always going to be a negative value in equations like these with squares. Alright, that's pretty much it. That's how you would go about solving this type of question in Algebra 1 and quadratic equations and squares of binomials.